hold on. Don't patronize me. We did this, the absolute value of x, if y equals the absolute value of x, what was the graph of that? Maggie? Yeah, it was a v. Okay, that was the graph of that, so you know, whatever. Here's the equation though, what if you have this? What if the absolute value of x equaled 3? You should be able to tell me what x could be. X could be, you have two answers, what are they? -3 and 3. But what if it was this? What if it was x plus 1 absolute value equals 3? You might be able to tell me the answer to that. Alex says,
2 and -2.
okay, if you put 2 in there, I agree, you get 3. If you put -2 in there, remember you have to do this first before you take its absolute value. If I put a -2 in there, -2 plus 1 is a -1, and the absolute value of -1 is +1, not 3. Somebody?
-4.
Ah, -4. -4 plus 1 is a -3, and absolute value of -3 is +3, so it is. Now, can anybody tell me how in the world we're going to do that when it gets really complicated? Grace Watson, I could tell you were thinking hard and long about it. Come on, okay. Yes, here's the deal. Let's say you have this, x minus 10 absolute value equals, I don't know, 20. Here's the simple rule you need to follow. Your first step is you need to isolate the absolute value. And we'll talk more about that later, just put that down. In this case it is. The absolute value sign is all by itself here. Okay? And then step 2 is you need to make two equations without the absolute value sign. One of them, one with the positive answer, and one with negative, which you won't understand until I explain. You ready? Get set, go. First of all, please understand this, one small, yes, important fact. If this was a -20, what would be my answer?
-10.
The absolute value of what number is -20? It's obvious. Said sarcastically. This is impossible to do. You can't do this. You can never get the absolute value of a negative number because what does absolute value do? Change it to positive. So if at some point you get an absolute value with a negative number, you can't do it. It's undefined. No, I guess the word no solution comes to mind. But that's not the case here. Here's what you do. Once you get this absolute value sign by itself, you rewrite the equation, the x minus 10, take away the absolute value signs, you make one of them just the way it is, equals 20. The second one has to be x minus 10 equals the negative of that. Because if you end up with a -20 in the absolute value sign, you're going to get +20 when you take its absolute value. So you make one with a -20, the other one with the positive, and that's your two answers. So I add 10, I add 10. One of my answers is 30. 30 minus 10 is 20, absolute value 20, 20. The other answer, I add 10, I add 10. X equals -10. If I put -10 in there, a -10 and a -10 is a -20, and the absolute value of -20 is 20. So those are your two answers that you would get. One with the positive there, one with the negative there. That's pretty crystal clear. Logan?
How'd you get 30?
Where?
You got 30.
Because here, I added 10 to this. This was a positive 20 plus 10 is 30.
I thought you made it into a negative.
I made it a negative, that's the second one. The first one, you write two equations. One of them, you keep it just the way it is. The second one, you make it negative at the end. Don't worry, we'll do more. You've just begun to fight. Right out of the book, how about this one? It's really not that hard if you just keep it straight here. Absolute value of x minus 6. Absolute value of x minus 6 minus 2 equals, I don't know, what's it say there? Negative 2. Can I have that?
No.
Yes, I can. Okay. Why can I have that when I just told you before I couldn't have that? Remember I said you have to isolate this first. So before you can decide that you can't do it, you gotta get rid of this. How do I get rid of a negative 2? I add 2 to both sides. And when I add 2 to both sides, I end up with a 0 over there. So now I have the x, absolute value of x minus 6 equals 0. When you end up with a 0 here, you're only going to get one answer, because you can't have a positive and a negative 0, it's just 0. So when will x minus 6 be equal to 0? You add 6, when x is 6. 6 minus 6 is 0, absolute value of 0, 0, 0 minus 2 is negative 2, so that works. Everybody happy there? Now, had this been a negative number after I moved that over, then I can't do the problem. But since when I moved it over it was. Another one you say, 4 times the absolute value of x minus 2 equals 80. Remember, you don't write your two equations until after you isolate the absolute value sign. I need this by itself first, so I have to do what? Get rid of that multiplying 4 by 5, divided by 4, divided by 4, and then I get absolute value of x minus 2 equals 20. And now once you do that, you write your two equations. One of them's going to be x minus 2 is 20, and the other one's going to be x minus 2 is negative 20. Adding 2, you get 22 is one of your answers. Adding 2, and negative 18 is one of your answers. And of course, you're going to ask, does that work? Sure. If I put 22 in here, 22 minus 2 is 20. Absolute value of 20 is 20. 20 times 4 is 80. If I put negative 18 in there, it's negative 18 minus 2. Negative 20, what's the absolute value of negative 20? Positive 20, positive 20 times 4 is 80. Those are your two answers. Stop me there if that made absolutely no sense. Are we going for the hardest one in history? Yes. Why don't they do multiple compound ones? How about this one? Oh, they don't seem very hard. I would have thought they'd challenge you a little bit more than this. How about this? Yeah, sure, why not? Do this one. 5 times the absolute value of z minus 3. Make sure I got this right. Plus 5 equals 25. Tell me what you think about that. That's all I got to say about that. Solve that. I can't believe I lost the sheet that had all of mine. Why? Answers? Clausing, did you get an answer? Noah says, what?
7 and negative 1.
7 and negative 1. Is there agreement out there? Oh, Clausing. Wait, David, did you agree?
Yeah, I guess.
Maybe there's hope.
You gotta divide, so you subtract.
Logan says he's got this figured out. Brian,
Z equals 3.
just 3?
I got,
Three.
Dissension in the ranks.
You get a zero.
Logan, is that what you got?
Yeah.
Alright, again, you need to isolate this first, before you do your negatives and all this, you have to subtract 5 first, subtract 5 first, that gives you a 20 over here. 5 times z minus 3 equals 20, divide by 5, so now z minus 3 absolute value equals 4. Write your two equations, z minus 3 equals a positive 4, z minus 3 equals a negative 4. Add 3, one of my answers is 7. Add 3, my other answer is negative 1. Did I do something wrong?
Wouldn't it be order of operations?
In which part? Tell me where. Here? Negative. Remember when you do any normal equation, if I have 3x plus 8 equals 15, what do I do first? You get rid of that. When you think of solving, what you're actually doing when you solve an equation is you're actually working backwards. So actually when you solve an equation, you do order of operations backwards. Okay. And that's a good point, because yeah, you always get rid of the adding, subtracting stuff first, then you do the multiplication division part there. You really, actually it's the same way if you even had a radical thing. You know, if you had 3x squared plus 8 equals $35. If you were solving that equation, you really do order of operations backwards. Remember, order of operations, say you do what? Grouping symbols. You do exponents, you do multiplication, division, then you do addition, subtraction. Well, solving an equation, it's like working backwards. The first thing you're going to do is subtract this 8, you get 27. 3x squared equals 27. You're going to divide, multiply next. X squared equals 9, and then the last thing you do is take the square root of both sides. And you get x equals 3. I can see where that's confusing. I don't understand. But we're fixed now? Do I have to give you another one, or are we fixed? Then what you're gonna do, lesson 74, I'm very excited about this. Anything that has in parentheses a number, 72, 73, or 74. I don't think there were that many. Well, wait, somebody